Today, we're going to be working with real-world measurement problems. Measurement is great if you want to know the distance between buildings. We're also going to be learning two methods to help you with word problems. The first method is sketch and reread. The second method might look a little familiar to you. Do you remember what that's called, that strategy? Did you say bar model? It is a bar model. I love bar models. So remember, during the video lessons, they're meant to be interactive. You should be doing the thinking, and you should also have something you can write on and something you can write with. Okay, let's do our first strategy, which requires sketching and rereading. I'm going to read the word problem. Max is 66 inches tall. Alan is 17 inches taller. How tall is Alan? So I always start with what I know without a doubt. What we know without a doubt is Max's height or Alan's height. You're right. We know without a doubt Max's height. So remember, it's a sketch. Sketches are not supposed to be masterpieces of art. They're supposed to be quick and easy. So I know Max. So I'm going to quickly sketch Max. And I'm going to put an M above him. So I know that's Max. You can even write it out. What else do I know? I know without a doubt that Max happens to be 66 inches tall. What else do I know? I know about Alan. Is Alan taller than Max, or is Alan shorter than Max? Please think about it. You're right. Alan is taller than Max. So I'm going to quickly sketch. And I'm going to make Alan taller. And I can put an A above for Alan, or I can write it totally out. Now, do I know how tall Alan is? Do I know his total height? No, I don't. So I'm going to put a question mark. But what else do I know without a doubt? I know, if I am comparing, those are my little dotted lines, I know that Alan happens to be 17 inches taller. So my sketch doesn't look pretty, but it helps me understand the word problem. Now we're going to reread it again, and we're going to look at our sketch to make sure our sketch matches what the word problem is saying. Max is 66 inches tall. Alan is 17 inches taller. How tall is Alan? So now we're going to really look at that question. How tall is Alan? And we're going to use an additional strategy, which we can use in both methods, which is writing an answer statement. We're going to turn the question, how tall is Alan, into a statement. We're going to write Alan is blank inches tall. So we have our answer statement right here. Alan is blank inches tall. Now we have to pick the right operation. Do you think this is an addition problem, a subtraction problem, a multiplication problem, or a division problem? How would you solve it? What operation would you use? Great. So many of my friends knew it was an addition problem because we knew in the end we wanted Alan to have more inches because we knew Alan was taller. So we knew that Max happens to be 66 inches, and I like to rate the units because we're always thinking about we know. And we know that Alan is 17 inches taller. And so many of my friends knew it was an addition problem. So this is a great one to use fact fluency for. I know what 6 plus 6 is. Do you? Say it out loud. So if you know that 6 plus 6 happens to be 12, what would 6 ones and 7 ones equal? Great. Did you say 13 ones? So I know the number 13 has 3 in the ones place, and it has 1 10. So it was a regrouping problem. So now what I want you to do is calculate your tens. We have 1 10 plus 6 tens plus 1 more 10. How many tens are going to go in the tens place? You're right. We had 8 tens. So in the end, we knew that Alan is 83 inches tall. So Alan is 83 inches tall. I always like to write it over here too. Great job. Now we're going to practice the other strategy, bar modeling. We've done bar models before when we were doing addition and subtraction. It's kind of the same, except now we're including inches or feet. Let's read the problem. Emmeline has 2 gardens. Her vegetable garden is 240 feet long. Her flower garden is 19 feet shorter than her vegetable garden. How long are both her gardens? So just like when we were doing our sketching and reading, you're plugging in what we know. First, if you remember, when we do bar modeling, we like to include our starting line. Let's plug in what we know. We know she has 2 gardens. We know she has a vegetable garden. We also know her other garden is a flower garden. Those are her 2 gardens. So do we know the length of her vegetable garden or her flower garden? You can always look back in the word problem. You're right. We know without a doubt the length of her vegetable garden. So we're going to draw a bar that represents the length of her vegetable garden, which we know is 240 feet long. Some friends like to write 240 in the box. Other friends like to write it on the outside of the box. Whoops. It's your choice. Now we have to think about the length of her flower garden. Is her flower garden longer than her vegetable garden, or is it shorter than the vegetable garden? You can look back in the problem and then say it out loud. You're right, it is shorter. So I'm going to start at my starting line, and I'm just going to make the bar shorter because we know her flower garden is shorter. Now, do we know how much shorter her flower garden is? We know that her vegetable garden is 19 feet longer, which makes it 19 feet shorter. Her flower garden is 19 feet shorter. So now we're going to reread it and make sure that our bar model matches all the things we know in our word problem. Does it match? Good job. Now we're going to look about what the word problem is asking us to solve for. It's asking us, how long are both her gardens? So it's asking us, how long both of her gardens are. So we're going to write an answer statement. We're going to take that question and we're going to make it a statement. So here's our answer statement. Her gardens are both blank long. You can even, instead of use her, you can use Emmeline. What we have to notice, do we know everything? No. We do not know how long her flower garden is. How would you solve for how long Emmeline's flower garden happens to be? We know it's going to be shorter than 240 feet. I like to put those units. So do you think this is addition, subtraction, multiplication, or division? Think about it. Great job. You're right. Since it's shorter, we are going to subtract because we want it to be less feet than our vegetable garden. Put it on pause and solve for how many feet long her flower garden is. So initially we have 0. In our ones place we have 0 minus 9. We need to get some ones over there. So we're going to regroup. We're going to move 1 10 over. So we no longer have 4 10s, we have 3 10s. And I know the difference between 10 ones and 9 ones happens to be 1. Now let's look in the tens place. We've got 3 10s. We're going to subtract 1 10. We're left with 2 10s. Hundreds. We have 200. We take away 0 100. We're left with 221 feet. So now we have to do step 2. We know her vegetable garden is 240 feet. We know her flower garden is 221 feet. What would they be all together? What are they together? I want you to pause the video and set up the problem. Is it addition, subtraction, multiplication, or division? Great job. You knew that it was going to be addition because we were combining the vegetable garden and the flower garden to get the total of both gardens. So you just need to add those together. Pause the video and do that now. You can stop the video now and go right to your IXL independent practice, or you can continue it for additional practice. You learned 2 strategies today. You learned read and sketch and bar modeling. You're going to do IXL practice today using both strategies. In IXL, when you click on this button, it will read you the problem. Let's read this problem together. At the coffee shop downtown, mocha cups are 7 inches tall. Hot cocoa cups are 3 inches shorter than mocha cups. Coffee cups are 1 inch taller than mocha cups. Which cups are the tallest? I want you to do this on your own. Remember, if you're picking a strategy, this is a perfect one to sketch. It's easy to draw coffee cups. Do a quick circle, 2 lines down, and connect them. That's how you make a cup. So pause the video, read the problem again, and sketch the problem. Now, there were 3 types of cups. I put M for mocha, HC for hot chocolate, and CC for coffee cups. Which one of these cups did we know without a doubt how tall it was? You're right. We knew that the mocha cup was 7 inches tall. The next type of cups was the hot chocolate cup. The hot chocolate cups are 3 inches shorter. So when I compare it to the mocha cup, I want to make it 3 inches shorter. So I know it's shorter. When I reread the word problem, I know that I have to compare my coffee cup to the mocha cup, and I know that it's 1 inch taller than the mocha cup. So I would want my coffee cup to be 1 inch taller than the mocha cup. Now we go back to the question, which cups are the tallest? Based on our sketch, we can tell that the coffee cups were clearly the tallest. So you would click coffee cups and submit. Let's try one more before you go into IXL all on your own. This time, we're going to use a bar model to help us with our strategy. Remember, for the bar model, you want to have your starting line. I want you to read the problem, and I want you to make a bar model. Remember, label whose car and do your bars. Put it on pause now and solve. Great, I hope you had time. Did you label Philip's car and Luther's car? Did you reread to figure out whose car was longer? Did you figure out that Luther's car was longer than Philip's car? So your bar should show that Luther's car is longer than Philip's car. Whose car do we know without a doubt how long it was? You're right. We knew without a doubt Philip's car was 12 feet long. Do we know what Luther's car is? Nope. So now, what do we know? We do know, when we were comparing them, that Luther's car is 2 feet longer than Philip's car. So that means Philip's car is 2 feet shorter than Luther's car. So you decide, is this an addition, subtraction, multiplication, or division problem? All right, solve it on your own. You'll see this in IXL. Good luck.